So let's talk briefly about perfect squares in regards to exponents, okay? I'm going to write them down. You have x squared, x4, x6, x to the 8th power, okay? The reason why these are perfect squares is because this, you have x times x, right? Because when you add the exponents, which is basically 1, well, if you multiply the same base, and the rule is you have to add the exponents, right? So you got to keep in mind this rule here. If you have, x to the a power times x to the b power, the rule is that you multiply the same base, so you can write it as one base and then add the exponents. Okay? So x squared, if you take the square root of x squared, you're going to get x. Why? Because x times x is x squared. All right? X to the 4th is, don't forget, it's x squared times x squared. So the square root of x squared is going to be, the square root of x to the 4th power. Okay, let me just rewrite that. All right? The square root of x to the 4th power is equal to x squared because of this reason right here. Okay? And the same thing for x squared. The square root of x squared is x because of this. X times x, we're adding the exponents. Okay, so the square root of x to the 6th. Okay, let's look at x to the 6th. X to the 6th breaks down as x cubed times x cubed. Okay, if we take the square root of x cubed, we should get x to the 6th. The square root of x6 is x cubed because of this, x cubed times x cubed. If we look at the 3's for the exponents, we add them. 3 plus 3 is 6. Okay, let's look at the last one. That's going to be x4 times x4. So if you take the square root of x to the 8th power, I keep writing a different number here. So let me try that one more time. Square root of x to the 8th, again, is x to the 4th because of this reason right here. So think of it as, when you multiply the same base, the exponents have to be identical so that when I add them, 4 and 4 gives me 8. All right, 3 and 3 gives me 6, 2 and 2 gives me 4, 1 and 1 gives me 2. And you can also look at the same thing for perfect cubes. Okay. It is the same concept. I'll just do a couple of examples. Okay, so x to the, let's see. X to the 3, x to the 6th, and x to the 9th. Okay, all of these are perfect cubes because x times x times x all have an exponent of 1. If I add those 3 1s, if you're multiplying the same base, which is x, and I add those 3 1s, I get x cubed. So the square root of x cubed is simply going to be x. All right? And here we have x squared times x squared times x squared. So the square root of x squared, x to the 6th power is x squared. Because if I take x squared times itself by 3 times and I add the exponents, I should get x to the 6th back. Okay, so you got to think of it in terms of that way. Here, remember, you have to multiply something itself 3 times. Because we're taking the cube root, right? Cube root means something times itself 3 times. Well, square root of x to the 9th is just x cubed. Because 3 times 3 plus 3 plus 3, if I add the exponents, I should get 9. So what we got to remember is this property of exponents here is really important. okay? So, go to the next page, and if we do a couple of examples, all right? We're taking the square root of y to the 8, okay? So, if we do that, okay, I want you to think of this, y 4 times y4. Why am I doing that? Is because I'm working backwards. I'm basically saying what times what, so that when I add the exponents, I get 8. Well, 4 plus 4 gives me 8, because if I multiply these two together, I need to add the exponents, and that gives me my original radicand back. So that leads me to believe that the answer is just y4. Okay? So keep that in mind. We have to remember the rules of exponents, all right? Let's look at another example. We're taking the cube root of 27a cubed, okay? Keep in mind that we can write this as cube root of 27 times the cube root of a to the third power, right? Now, is 27, can we take the cube root of that? Is that a perfect cubed? Actually, it is. It's a very common cubed. 3 times 3 is 9, times 3 is 27. So it helps to know the perfect cubes off. If you don't, then just review those because they're very common and you're going to see those quite often. The cube root of 27 is a common perfect cube. You see that a lot. So it is actually 3, because 3 times 3 times 3, if it times itself, will give you 27. And you look at this one, okay, a to the cube power, a to the third power is also a perfect cube, which is a. Because a times a times a, if you add the exponents of 1, you get a cubed. So my answer is going to be 3a, okay, because 3 times a is 3a, all right? So break them down into separate cubes is maybe a little easier. That way it's not overwhelming. Okay, so interestingly enough here, we can do another example. Let's see. Cube root. Let's see, 5. A5, B5. Okay, we can simplify this as the 5th root of a to the 5th and the 5th root of b to the 5th. So you can basically write it as separate radicals. Maybe a little easier for you to visualize. It basically what multiplied itself 5 times. Well, a times a times a times a times a. If you add all the exponents of 1, you should get 5. Okay? Because that's what that is. This is basically a times a times a times a times a. If we add all the exponents, we know that's just going to be a to the 5th power. Okay, so a number, the radicand is a, so if I multiply a itself 5 times and I add the invisible ones, exponent ones, I get a to the 5th. So the 5th root of a to the 5th is a. And then the same here. If I take b and I multiply itself 5 times, I'm just going to get b to the fifth. So the fifth root of b to the fifth is b. So my answer is a to the b power, a over b, sorry.